All right, 2.6, rational functions. We're going to do some more graphing here, and we're really going to put together a lot of the things we've talked about so far in Chapter 2 with what we learned about graphing and zeros and all sorts of good stuff like that. So definitely break out your graphing calculators. We're going to be using them a bunch, and here we go. So what is a rational function? All it is when we have a quotient and we have polynomials on the top and on the bottom. All right, as long as the bottom's not 0, which we wouldn't want to deal with 0 on the bottom ever, right? So anytime we have an x or an x squared or an x cubed or anything going on the top and we have something on the bottom, we have a quotient, we'll call that a rational function. All right? So we know we cannot have 0 on the bottom. So in general, we'll read the sentence, the domain of a rational function includes all real numbers except values that make the denominator 0, right? We've talked about that before. So much of this chapter is all about what happens when we get close to the numbers that make this 0. All right, so we'll talk about this here. So let's look at example 1. F of x equals 1 over x. So let's find the domain here. So we know right away the domain is x is all real numbers except for x cannot equal 0. But now we want to figure out what's going on when we're getting close to 0. So I'm going to go ahead and bring up the graph here. I've already gone through, I actually put in all the equations that we're going to need in this section just as a time saver. So here's the first one. If I graph 1 over x, I get this. Right? We're going down here and here. So just kind of a quick sketch of what we saw in the graphing calculator. We're looking like this. And we've seen these graphs before. This is the parent function 1 over x. All right? So what's happening as we're getting close to x equals 0? Right? Well, as we're going to the left, right, as we're approaching this from the left side, we're going up to positive infinity. Right? So as we approach from the left, y goes to infinity. And as we come from the right, we're going to keep going down to infinity. So y goes to negative infinity. All right? So the way we're going to do that is, let me skip a slide here. In example 1, the behavior of f near x equals 0 is denoted as follows. As f of x, as y approaches negative infinity, x approaches 0 from the left. Right? It's moving right, but from the negative side, from the left. All right? And so another fancier way of saying approaches negative infinity is decreases without bound. Okay? And on this one, increases without bound as we come up here from the right. Okay? So from the right, we're increasing without bound. All right, so you can go ahead and try exercise 5. They have the tables for you. Plug in these values. You might want to use your graphing calculator to do them quickly for you, but you're going to quickly figure out what the domain is, right? And so you'll be able to find some vertical and horizontal asymptotes, the lines that we cannot cross. All right, lines that we cannot cross. Really quickly here, I think we didn't really talk about this, but on example 1, we would have a vertical asymptote at x equals 0, a horizontal asymptote at y equals 0. Y equals 0 would be our horizontal asymptote, and x equals 0 is our vertical asymptote. All right, so once again, try example 5 right there. All right, so let's talk about this. What is the definition of an asymptote? Asymptote is a line we're not going to cross, and as x approaches a, we'll call that a vertical asymptote if the y values are going to infinity or negative infinity. Same thing going the other way. If our x values are going to negative infinity, what's the line it doesn't cross? Okay, so horizontal asymptotes, horizontal lines we don't cross. Vertical asymptotes, vertical lines we don't cross. So here's a couple of examples. This is the graph of 2x plus 1 over x plus 1. Just a little reminder, if we were to put these in our graphing calculators, it wouldn't graph right unless you put parentheses around things in the right spot. And then we would look, okay, where are we not going to cross? Y equals 2 and x equals negative 1 for some asymptotes. All right? And so you'll notice on the second example, there is no vertical asymptote. It'll go out forever. Okay, and on here, notice this one. This is interesting. They're both going to positive infinity, but it still creates an asymptote, a line we're not going to cross. All right, so couple rules here for finding asymptotes. This looks really complicated. It's not. Quick 3 steps here. We have these big, ugly, long polynomials, right? But what we really care about are the leading degrees here. So we're going to always check the degree of the numerator and the degree of the denominator. And comparing those is going to tell us what our asymptotes are. All right? So vertical asymptotes are always just going to be the zeros of the denominator. All right? Find the zeros of the denominator, and those are your vertical asymptotes. Horizontal asymptotes change a little bit. So here's what's going on. If n is less than m, if we have something like this, x cubed over x to the 4th, and then a whole bunch of other stuff, plus, a whole bunch of other stuff, okay? If we made these numbers really, really big, like 1,000,000 cubed, over 1,000,000 to the 4th, 3, 4, 5, 6 zeros to the 4th. That's going to be a fraction super, 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 super tiny, right? And super, super tiny fractions are pretty close to 0, but we're never going to actually get to 0. So we're going to have a line we don't cross, and that's y equals 0. So the shortcut, if our denominator's bigger, we can't cross 0. If the denominators are exactly the same of the leading terms, if we have x to the 4th over x to the 4th, whatever our coefficients are is just going to be our asymptote. Because we're never going to actually get there because we're going to have extra stuff here hanging on to the end. So it's never going to be exactly a divided by b because there's other stuff that needs to divide. So we can never cross the line y equals a over b if the exponents are exactly the same. And if the top, the numerator, is bigger, we're not going to have a horizontal asymptote. We're going to have something different called a slant asymptote, and we're going to deal with that shortly. But for the time being, no horizontal asymptotes if the numerator is bigger than the denominator. Let's try some. Here we go. Find the vertical and horizontal asymptotes. All right, I'm going to start with the vertical. Zeros of the denominator. X squared minus 1 equals 0. X squared equals 1. X equals plus or minus 1. Boom. Those are my vertical asymptotes. Can't cross those lines. And let's talk about the horizontal asymptotes. I see a 2 versus a 2. So since they're even, I'm going to divide the coefficients. 2 divided by 1. We're going to say y equals 2 over 1, which is y equals 2. And that's our horizontal asymptote. All right? So if we went and threw this on the graphing calculator, which is already here, let's turn it on. Let's see what happens. All right. 2 asymptotes that are vertical, and these are going to be at plus and minus 1. All right, we can see 1 and negative 1 here. Sorry, 1 and negative 1. It's not going to cross. And then we're not crossing the horizontal line y equals 2. Right? It flattens off here. It's going to get close, but never cross that line. So for b, same thing. We're going to go ahead and take a look at the denominator. X squared minus x minus 6 equals 0. Let's factor that. We're going to have x minus 3 and x minus, or plus 2. So we've got x equals 3, x equals negative 2 are the vertical asymptotes. And then, since they're even, 2 versus 2, we're going to say 1 divided by 1, y equals 1, horizontal asymptote. Take a quick look at the graph just to verify. Always going to want to do that. Y equals, it's our third graph now. And there we go. Y equals, oh, is this the right one? 3. And x equals, did we lose one? Yes, we should have another asymptote at 2 there. Let me zoom in and see what's going on here. oops, window. And we'll make it a little very small, 0 to 5 graph. Aha, there we go. So on this one, actually, we're going to have a little hole right here at -2. So it can't cross that spot. So there's a dotted line here. It just doesn't cross it. It has a little hole. It's jumping over the top of it. At that point, x equals -2. Okay, so a couple things to look at. We're going to want to look at our graph to confirm all of these things. But we can see right here the little hole at x equals -2. All right? So give that a shot for yourself on x cubed over x squared minus 1. Remember what happens if the numerator's bigger than the denominator for your horizontal asymptote. All right, so here is the steps for analyzing all the graphs for rational functions we're going to come to. It's not as bad as it looks. Simplify if possible. Of course, we're going to do that, top and bottom. We're going to find the y-intercept. The y-intercept's easy because we just plug in 0 for x. We can do that. We're going to define the zeros of the numerator and the denominator. The zeros of the numerator give us our x-intercepts. The denominator give us asymptotes. Okay? We'll draw as much as we can in there for the horizontal asymptote based on the rules for the top and the bottom. And then we'll plot some more points. You'll see what that looks like in a second to get our graph. So here we go. 3 over x minus 2. First step is simplify. It is. Let's talk about the zeros of the numerator. There's none. How about the zeros of the denominator? X minus 2 equals 0, so x equals 2. That's going to be an asymptote. Okay, at that point, let's plug in 0 here. Make that 0, so that's 3. So f of 0 equals 3 over -2. -3 halves, -1.5. Okay. And what about our horizontal asymptote? The bottom is bigger than the top. It's x to the 0 up there. If the bottom is bigger, we're going to have a y equals 0 horizontal asymptote. And so here's what we got so far. We have our graph. We have an asymptote at 2. At y equals 0. We know that if we plug in 0, we get -3 over 2, which is right there. Okay? Now, here's the thing about asymptotes. Asymptotes are going to act like magnets as we go out to infinity. So I know that since I'm touching this dot, I must curve like this, because as I go down to infinity for x's and y's, I'm going to get sucked really, really close to my asymptotes. All right? So the other question is, what happens over here? Either over here or over here. So we need one more point on the other side of this vertical asymptote to figure out what's going on. So let's plug in one point that's bigger than x equals 2. So maybe x equals 3. 3 over 3 minus 2 equals 3 over 1. So if we plug in 3, we get out 3. Let's find that. 3 comma 3 is right here. So we know, since we're going to the asymptotes, our curve must look like that. All right? Can't cross those asymptotes. See if you can use the same kind of thinking to do number 31. All right, example 4 goes the same way. I'm going to start moving a little faster through these. So as we look at this, we're going to do everything we can. So we know that x equals 0 from the bottom. We know that 2x minus 1 equals 0. So we've got x equals, so sorry, this is a asymptote. X equals 1/2 is a 0. We know that y equals 2 divided by 1 for our asymptote. And let's go ahead and graph this. So y equals 2. And x equals 0, like this. And we know that if you plug in, let's see, x equals 1/2 is here. Oh, the one thing I forgot to do is plug in 0 for x. Over 0. Oh, can't do that, so we're not going to have any intercepts. Sorry, we're not going to have a y-intercept. But we do know this part of the curve. It's going to go out to the asymptotes and curve down. We just need to know what's happening on the other side of this asymptote. So let's plug in a negative number. Let's plug in, how about -1 for x? So 2 times -1 is -2, minus 1 is -3. Over -1 is +3. So if we plug in -1, we get 3. And so our curve must look like that as it gets sucked towards the asymptotes. Okay? See if you can do the same thing for 35. All right, getting a little more complicated here. X over x squared minus x minus 2. Very first thing we've got to do is simplify if possible. We can factor the denominator. X minus 2, x plus 1 makes things easier for us. Okay? So we're going to have a 0 at x equals 0. So we're going to have a vertical asymptote. So this is our 0 from the numerator. A vertical asymptote at 2 and -1. We're going to have a horizontal asymptote. X to the first divided by x squared. The bottom's bigger, so y equals 0 automatically. And let's go ahead and see what happens if we plug 0 in. Oh, we already have that. X equals 0 up here. We've got enough to graph, at least to start. Okay, so let's do our asymptotes. Y equals 0. Our verticals are at 2 and at -1. All right, so now a little bit trickier for our all our curves. When we go to the outside, we're going to hug the asymptotes. We know that we're going to cross right here. Okay. On this one, we need something further out. Let's use 3. All right, so if I plug in 3 over 3 minus 2, and 3 plus 1. So 3 over 1 times 4, which is 3/4. So if I plug in 3, I get 3/4, right about there. All right, we're going to have ourselves that curve. Yeah, how about something over here? How about -2? So -2 over -2 minus 2, -2 plus 1. And so we're going to have -2 over -4 times, what do we have here? -1. So we'll have -2/4, which is 1/2 negative. And so we're down here. And we must curve. All right, the last point in here. We don't know what our curve is doing in between the asymptotes in here. All right, so we're going to need a couple more points in here. So we could keep going through and plotting them, or let's let the graphing calculator be our friend on these ones. Okay, so as we get to the more complicated ones, definitely okay to just use your graphing calculator and pull some points out. Okay, we want to make sure the behavior makes sense, but it's okay to use it. So here is x over x squared minus x minus 2, and we turn it on and graph it. Oh, bad window. Still the same window from our last problem. -10 to 10. Graph that. All right, so what's going on in here? Right, so remember that was in between -1 and 2. So let me change my window for -1 and 2. Graph that. All right, so it's coming down like this and turning over. If I back this out a little bit, -50 to 50, I think we're going to get a clearer picture. Not quite as much, -100 to 100, just zooming out, zooming out, zooming out. And it's just doing more and more of this. Let's see if it works better if I make this a little wider for us. No, not really helping. So sorry, if you're looking at, it's because of the computer version of the calculator. If you were looking on your graphing calculator, in here, we would see this happening in the middle. Okay, so you might want to plug that in on your graphing calculator and take a look at it. If we went back in here to -1 to 2, you can kind of see that that's what's going on here. It's coming down and coming down again. Okay, hard to see, sorry, on the computer calculator. All right, but use your calculator on these, see what the shapes should look like, find all your asymptotes, vertical and horizontal, graph the curves. Okay. All right, 2 more just to wrap this up. Example 6. We're going to factor first, x minus 3 and x plus 3 all over. We can factor this as x minus 3 and x plus 1. All right. So on this one, it's nice because we get to cancel some things when we're solving, but we still need to remember that x can't be 3. X cannot be 3, otherwise it would screw up the denominator. All right, so that's going to be a hole, one of those things we saw before where we're just going to jump right over it. Let's find our asymptotes on this one. 2 with 2, so we're going to say y equals 1. And our horizontal asymptotes are going to be the denominators of the 0, x equals -1. All right, so if we were to graph this, we've got y equals 1. We're going to have x equals -1 asymptotes. All right, I've got this drawn up on the graphing calculator here. Let's take a look. Y equals, see if it comes out looking okay. Change my window. Oh, change the y's. Okay, so it's going to be one of these graphs here, taken off like that. So we have our shape here, and we have our shape here. There's just one thing that we need to remember, that x can't be 3. So at 3, right here, we're going to need to put a little hole in there, which we'll indicate by a circle, right? We have to jump over the 3 right there. It's not going to work out. All right, last thing we need to talk about here are slant asymptotes. All right, slant asymptotes are going to be when we have the numerator's degree bigger than the denominator's degree. We have a diagonal asymptote. Here's what we do. We need to find that asymptote, do long division to start. X minus 1 goes into x squared minus x minus 2. It's going to be x. X squared minus x is going to be -2x minus 2. And so at careful on that one. Am I right here? I believe I'm right. Let me make sure I didn't write the problem down wrong. Minus a oh, there's my problem. Minus a negative. Sorry, that's not there. And so now we just have a -2 at the end. -2 over x minus 1. So here's what's going on. In this one, we could never have y equals x, because x is always going to have this remainder hanging off of it. So we can never, ever touch the line y equals x, which looks like that. So that's our slant asymptote. Okay. I also know, because on this one, we have, sorry, it's covered there, x minus 1. We know that x cannot equal 1, so that's our vertical asymptote at 1. We're going to look like that. Okay? And if we were to go in here and graph this thing, we're going to hug the asymptote here and here and have a nice curve. You can put this in your graphing calculator and take a look at this as well. It's going to look just like that. All right? So, number 65, get your slant asymptote, get yourself a vertical asymptote, and put it in your calculator to see the curve. All right, to finish up these last two problems, I'm not going to run through really quick. You can try them if you want some extra credit on 8 and 9, 77 and 81. All right. On these problems, these are more of just plugging them in. You can take a look at trying these if you would like some extra credit, 8 and 9. So I'll leave you with those, and I'm sure we'll have plenty to go over next time I see you in class. Good luck.